This product training module highlights transient blocking units as an important circuit protection technology available to the market. We will review the operation of the TBU device, product offerings, target markets, and solutions with a focus on RS-485 port protection as an application example. By the end of the product training module, we hope the viewer will have a better understanding of the operation of a TBU device and the use of the TBU device in a typical application providing enhanced circuit protection performance. Bourns delivers the most comprehensive line of circuit protection technology and solutions in the industry. At our engineering centers in Riverside, California, Carrollton, Texas, Heredia, Costa Rica, Zuzenberg, Slovenia, Bedford, UK, and Linkou, Taiwan, we design a full range of overvoltage and overcurrent protection technologies. Today we would like to introduce you to our TBU high-speed protectors. Bourns offers world-class technology and applications expertise that is the result of many years of circuit protection engineering, design, and support. Bourns' global reputation for extensive application knowledge, quality products, innovative protection strategies, and a wide range of technologies ensures that we can provide the right circuit protection solution for your needs. Depending on the customer's requirements between the cost of low-level circuit protection versus the transient threat level, choosing the right protection level at the design phase can bring significant savings down the line. The basic overvoltage and overcurrent protection scheme used for a typical signal port is shown here. The TBU device is placed in series to block transient currents and provide voltage isolation. OVP2 limits the voltage at the input to the protected circuit and provides a path for transient current until the TBU device is triggered and transitions to the full blocking state. OVP2 may not be required if adequate protection is designed into the protected circuit. After the TBU HSP is triggered, OVP1 limits the voltage across the TBU device to a safe level and also provides a current path for the remainder of the transient event. A GDT can be chosen for OVP1 when used to protect high-speed communication lines such as DSL, Ethernet, or LVDS. An MOV can be used for OVP1 for slower speed applications such as voice or RS-485. The OVP1 device should be chosen so that it does not trigger during power cross tests. The TBU is a silicon-based solid-state resettable device, which is placed in series with a signal path. The TBU device trips in approximately 1 microsecond, T-block, once line current exceeds the TBU device's trigger current, or I-trigger. When in the tripped state, the TBU device restricts line current to less than 1 milliamp. In this state, the TBU device will block all system voltages and any other voltages, including the surge, up to rated limits. After the surge, the TBU device resets when the voltage across the TBU device falls to the V reset level. The TBU device will automatically reset on lines which have no DC bias or have DC bias below V reset, such as unpowered signal lines. If the line has a normal DC bias above V reset, the voltage across the TBU device may not fall below V reset after the surge. In such cases, special care needs to be taken to ensure that the TBU device will reset. Otherwise, an automatic or manual power down will be required. The TBU device performance is shown here in Lightning and AC power cross. During the lightning pulse, the blue current line is rising to the trip level, I trip. The TBU device blocks the current signal even when the voltage continues to increase. During the AC power cross, the TBU device turns on and off every cycle, and the blue line shows the TBU device triggering in both positive and negative pulses. The impulse speed of the TBU device is shown here, where the reaction time on the green current line shows a limit response of 100 nanoseconds, with a duration of 800 nanoseconds. A key feature of the TBU device here is the low 100 nanojoule let-through energy that passes through to the downstream circuitry. This low energy signal provides opportunities for IC designers to design smaller ICs with lower energy dissipation. The TBU device is typically placed in series between the port and IC. As the Bourns TBU HSP has no connection to ground, The only capacitance added to the signal line is the parasitic capacitance from the device mounting pads to ground. The capacitance can be minimized by eliminating ground plane below the device on the printed circuit board. This minimizes the effect that the TBU HSP will have on the bandwidth of the protected circuit. Here you can see the low insertion loss of the model TBU CA085300WH device in a 50 ohm LVDS test circuit application up to 3 GHz. This slide shows a universal AC protection scheme, also known as the UACP. The UACP has a fuse, a primary protector, a TBU HSP, and a TISP device. UACP is used to protect the AC lines from overvoltage and overcurrent threats. Line power is applied to the left side port, and protected equipment is connected to the right. In this slide, we talk about the functioning of the UACP. The operation of the circuit is best described moving from right to left, starting with the TISP device. If a voltage event, swell, should trip the TISP device, ACTP, it will momentarily short out the AC line. The excessive current drawn will trip the Bourns TBU high-speed protector, or HSP, device into its blocking state. When the TBU device blocks the excessive current, the protected load and TISP device are essentially disconnected from the AC line, protecting both from damage. As the TBU HSP blocks the current, the input voltage may continue to rise until the Bourns primary protection, in other words ISOMOV, GMOV, MOV, or PTVS, clamps and limits the voltage below the TBU device's maximum blocking voltage rating. Should the voltage continue to rise until the current through the primary protection exceeds the device's surge rating, the fuse device will open and permanently disconnect the circuit from the AC line. Secondarily, if the protected load attempts to draw in excess of the TBU HSP's trip current, the device will go into the blocking state and the circuit will behave as described earlier. Bourns offers a new generation of TBU HSP products in 6 product families. For general use applications, the TBU DF series offers a dual bidirectional TBU HSP device with a choice of 2 input voltages and 5 trigger currents. The TBU CA series offers a single bidirectional TBU device with a choice of 5 input voltages and 5 trigger currents. The TBU CAQ series of devices is the AEC Q101 compliant version of the TBU CA series. So far, 6 TBU CA devices have been qualified as AEC Q101 compliant. The TBU DT series offers a dual unidirectional TBU HSP device with a choice of 2 input voltages and 4 trigger currents. For specific applications, the TBU DBQ series offers a dual bidirectional TBU HSP with a choice of 1 input voltage and 1 trigger current. It is an AEC Q101 compliant device. The TBU PL series offers a dual 50 ohm bidirectional TBU HSP with a choice of 4 input voltages and 2 trigger currents, and an added feature of both voltage and current triggering. The TBU RS series offers an integrated solution for RS-485 port protection. The TBU RS series helps reduce the component count, thereby saving board space. Circuit protection is a critical parameter in some markets and applications. TBU devices used in conjunction with Bourns overvoltage products provide superior circuit protection. Here's a list of applications where a TBU device can offer superior circuit protection. In the telecom market, Bourns' extensive product portfolio offers a complete circuit protection solution to required standards in T1E1 interface, VDSL, voice and gigabit Ethernet ports. For the industrial market, the combination of TBU devices with TVS diodes, MOV or GDT products ensures that high surge protection standards are met while data transmission rates are also maintained. The new TBU RS device is an integrated solution for RS-485 port protection. This approach not only ensures that high surge protection standards are met while maintaining the data transmission rates, but also reduces the number of components on the PCB board, thereby saving space. Here is an example of how a TBU HSP can provide a solution to an automotive application. In electric vehicles, the battery packs consist of many individual cells stacked in strings. The strings are connected in parallel. Damage to any individual cell can cause overheating, which can result in an excess current being drawn from that cell. This, in turn, could cause further heating, resulting in damage to the entire battery pack. Battery sensing and balancing is therefore needed for safe functioning of the battery pack. This is carried out by the Battery Management System, or BMS. The specially designed and AEC Q101 compliant TBU DBQ series meets the protection needs of battery sensing and balancing functions carried out by the BMS. The AEC Q101 compliant TBU CAQ series offers a single bidirectional TBU device with 3 input voltage and 4 trigger current options for various automotive applications. In this specific example, we evaluate the advantages and benefits of the TBU device in an RS-485 application. On the left, you can see the traditional 485 circuit diagram showing 2 10-ohm resistors and 2 12-volt TVS diodes. While this solution meets RS-485 transmission protocols and fulfills lower tier protection, the disadvantage for some RS-485 applications with potential surge transients is that the solution does not provide any AC power cross protection, and the 2 10-ohm resistors are not resettable when they're damaged. For the RS-485 application that requires high-energy surge protection, the circuit on the right with TVS, MOV, and TBU devices should be considered. This solution offers resettable AC power cross protection, irrespective of surge duration or rate of repetition, has no let-through energy to sensitive downstream chipsets, and provides wide operational bandwidth for high-speed data rates. The TBU RS series provides a similar level of protection with the added advantage of lower bill of material component count and reduced board space utilization. Here, electrical performance data on the RS-485 solution using TBU high-speed protectors, TVS, and MOV products is shown. Reaction to ESD per IEC 61000-4-2 and surge 1.2 microseconds rise time and 50 microseconds fall time with 5 kilovolts peak voltage are shown on top, while the graphs below show responses to AC power cross under 120 volts RMS and 28 volts RMS, demonstrating the TBU device operating as expected with lower energy let-through and fast resettability. Based on ADI's application note, there are 3 different EMC compliance solutions. Each solution provides a different protection capability. The configuration and protection scheme 1 is CDSOT23-SM712. The configuration and protection scheme 2 is the combination of TISP 424OM3BJR-S, TBU-CA065-200-WH, and CDSOT23-SM712. Once the TBU device is used in the circuit, the transient voltage can be up to 4 kilovolts, level 4. If the GDT is accompanied with the circuit, the transient voltage can be above 6 kilovolts, level X. X can be any level, above, below, or in between the others. The level shall be specified in the dedicated equipment specification in accordance to the IEC standard. The configuration in protection scheme 3 is the combination of 2038-15-SM-RPLF, TBU-CA065-200-WH, and CDSOT23-SM712. Here are some TBU HSP design tools. If you're curious and would like to know how powerful TBU high-speed protectors are, just follow the links. Information about the RS-485 evaluation boards and the demo videos can be found here. Bourns TBU high-speed protectors offer high-density integrated component technology and enhanced surge protection in small-sized packages for high-speed communication applications. Continuous product development enables Bourns to provide circuit protection solutions for changing market requirements. Bourns circuit protection semiconductor products can bring significant benefits and enhanced performance to your application. Visit www.bourns.com for more details.